Hello, so in today's video, we're just going to continue from the previous video yesterday where we looked at proving this quadratic formula. So this formula tells you the solutions to the equation ax squared plus bx plus c equals 0. So this here is your solution or your solutions potentially to this quadratic equation there. So a couple of questions. So number one, when do real solutions exist to this equation? So when do we get numbers, x numbers that are actually real numbers on the real number line? And also the second question here, how many real solutions exist? Do we have just one real solution or do we have multiple real solutions? So these are two questions we're going to consider today. And to consider this, we need to know about something called the discriminant. So I've written here a definition of what this word discriminant means. So consider a quadratic expression ax squared plus bx plus c, and a, b, c are non-zero numbers, non-zero real numbers, I should say. So the discriminant of this quadratic expression is defined to be b squared minus 4ac. So that is what the definition of the discriminant means. So it's like an example down here. So let's say you've got 2x squared minus 4x plus 8. So the discriminant of this quadratic, so discriminant of this particular quadratic is going to be b squared. So the a in this case is 2. The b in this case is minus 4. The c is 8. So your discriminant is going to be b squared, which is minus 4, all squared. Subtract 4 times by the a, which is 2, times by the 8, which is the c. And if you calculate this, you get 16 there. Subtract 4 times 2, which is 8, times 8 again, which is 64. So 16 take away 64, and that's going to be negative 48. So the discriminant of this quadratic is negative 48. So that's how you calculate a discriminant, or an example of how you do it. So why is this important? Well, I mean, if we look at our formula back here for the solutions to this quadratic equation, we see that this discriminant is here. So we take the square root of this b squared minus 4ac. So let's just make a note here that this is the discriminant. Okay, so that's part of our quadratic formula. So why is this significant? Well, let's look at this slide here. So if y is a real number, then if the square root of y is a real number itself, then it must mean that y is greater than or equal to 0. You can only take the square root of a positive number or a number that's equal to 0. Because yes, if you take a number and you take the square root of a negative number, then that is not a real number. So the key thing that we've got to bear in mind is that if we want this equation here to have real number solutions, this discriminant cannot be less than 0 because we can't take the square root of a negative number. So let's kind of make a point of this on a new slide here. So if solutions to this equation ax squared plus bx plus c equals 0 exist, then, sorry, let me write that again. So then it better be true that b squared minus 4ac is greater than or equal to 0, because if b squared minus 4ac is less than 0, then the solution that we get, x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So this is not a real number because this number there would be negative. So the key thing that we want in order for real solutions to exist, is you want b squared minus 4ac to be greater than or equal to 0. So we want the discriminant to be greater than or equal to 0 for real solutions to exist. So that's what we need. So, okay, if we go back to this second question that I mentioned here, so how many real solutions exist? So that depends on the value of b squared minus 4ac. So if b squared minus 4ac is equal to 0, then what happens? So we get a solution x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. But this number here, if that's 0, then the square root of 0 is just 0. Square root of 0 equals 0. So therefore we get a solution minus b plus or minus 0. Well, that's just minus b, divided by 2a. So therefore we get one solution. So one real solution. Okay, so we get one real solution when the discriminant is equal to 0. And when the discriminant is greater than 0, then we get, as you can imagine, we're going to get two solutions. So when b squared minus 4ac is actually strictly greater than 0, then we get our two solutions, x equals minus b plus or minus the square root b squared minus 4ac, all divided by 2a. So we get a positive number there. The square root of a positive number is a positive number. We're adding or we're subtracting that positive number. So we get two solutions. So two real solutions. Okay, so to summarize this then, just to summarize everything we've looked at today. So the discriminant, of a quadratic ax squared plus bx plus c is defined to be b squared minus 4ac if b squared minus 4ac is less than 0, then no real solutions. So no real solutions exist for the equation ax squared plus bx plus c equals 0. Now, if b squared minus 4ac strictly equals 0, then one unique real solution exists for the equation ax squared plus bx plus c equals 0. And finally, if that discriminant b squared minus 4ac is actually greater than 0, so if b squared minus 4ac is greater than 0, then two real solutions exist for that equation. So exist for ax squared plus bx plus c equals 0. So the key thing is that we can actually just look at this discriminant value, this b squared minus 4ac value, and we can actually determine straight away whether we're going to have no real solutions, one real solution, or two real solutions. So yeah, we can use this discriminant to make that distinction with these quadratic equations.